This tutorial is for 4th grade, Module 5, Lesson 7. In this lesson, we're going to look at the multiplication that takes place when we find equivalent fractions on a fraction model. Before I begin, I'd like to review the parts of a fraction. The denominator of a fraction tells us how many pieces the original model has been divided into. The numerator tells us how many pieces we're looking at, focusing on, or in this case, are shaded. This first model was showing us 1/2 because we broke the whole into 2 equal pieces. So that's where we get the 1/2. When we divided the model in 2, we actually doubled the number of pieces that made up the whole. Instead of having 2 pieces make up the whole, we now have 4 pieces that make up the whole. And we also doubled the amount of pieces that were shaded. Instead of having 1 piece shaded, we now have 2 pieces shaded. So we doubled the amount of pieces that were shaded. Another way to look at this is we multiplied the number that made up the whole by 2, and we multiplied the number of pieces shaded by 2. Now the size of the pieces changed, but we're looking at the number of the pieces that make up the whole and make up the shaded portion. Let's look at another example. We'll look at the original fraction. Again, the original fraction is 1/2 because there's 1 piece shaded out of 2 that make the whole. This time we drew 2 lines across, breaking it into 6 pieces in all. So instead of having 2 pieces that make up the whole, we multiplied that by 3, or tripled it. Now we have 6 pieces that make up the whole. And instead of having 1 piece that's shaded, we also tripled that amount. Now we have 3 pieces that are shaded. So we multiplied both the numerator and the denominator by 3 when we drew our lines across. And we ended up with 3/6 being equivalent to 1/2. Let's look at a couple more examples. For problem C, again, we started by breaking the model into halves. So I have 1 shaded piece out of the 2 that make the whole. This time I divided it into 4 rows. So now instead of having 2 pieces that make up the whole, I have 8 pieces that make up the whole. And instead of having 1 piece that is shaded, I have 4 pieces that are shaded. That means 1/2 is equivalent to 4/8. Now look at one more example over here. Again, we're starting with 1/2. And if we look, now we've divided it into 5 rows. So instead of having 1 piece shaded, I now have 5 pieces that are shaded. And instead of having 2 pieces that make up the whole, I now have 10 pieces that make up the whole. So 1/2 is equivalent to 5/10. In the next section, we're given some fractions and we're going to decompose them just like we did before to show equivalent fractions. This is an open-ended question. I can divide the fractions any way I choose. So I'll start with the first model, which I can see is showing us 1/4. There's 1 piece shaded out of the 4 that make the whole. I'm going to divide this one into 3 rows. That means instead of having 1 piece that's shaded, I now have 3 pieces that are shaded. And instead of having 4 pieces that make the whole, I now have 12 pieces that make the whole. That means that 1/4 is equivalent to 3/12. On the next model, I have a fraction that is 1/5 because there's 1 piece shaded out of the 5 that make the whole. I'm going to divide this in half. That means instead of having one piece that's shaded, I doubled that amount. I now have 2 pieces that are shaded. And instead of having 5 pieces that make up the whole, I doubled that amount as well. I now have 10 pieces that make up the whole. 1/5 is equivalent to 2/10. I've started my last question with 2 fraction models that represent 1/3. I divided each model into 3 pieces and I shaded in 1/3. We're going to decompose each of these models to show equivalent fractions. The first model will be divided into 6 and the second model will be divided into 9ths. Well, if I have 1/3 and I need to divide it into 6ths, that means I need to divide it in half. Because now instead of having 1 piece shaded, I have 2 pieces shaded, and instead of having 3 pieces that make up the whole, I have 6 pieces that make up the whole. 1 times 2 is 2, 3 times 2 is 6. So that's how I turn my thirds into 6. I multiply the numerator and the denominator by 2. In the next model, we need to change our thirds into 9ths. Well, if I multiply 3 times 3, that would give me 9 pieces that make the whole. So that means I'm going to divide it into 3 rows. So you can see the 9 pieces that make the whole, and you can also see that we have 3 pieces shaded instead of just 1. That means that 1/3 is equal to 3/9. And to take it a step further, since 1/3 is equal to 2/6 and 1/3 is equal to 3/9, we can also say that 2/6 is equal to 3/9. Just some logical thinking there.